Welcome. Today we start Unit 3. Transformations. On page 31, we'll be talking about functions. Okay. So take a minute to make sure you have that written down. Okay. So let's turn to page 31. And today is the 25th. So our objective for today is to evaluate function notation. Evaluate and use, evaluate a function. And utilize function notation. Okay. So what is a function? I believe blue is definition. Okay. A function is a rule that pairs every x in the domain with one and only one y value or f of x value in the range. Okay, so what is a domain? A domain is all x's that are inputs to the function. So this is what we put in to a function in a range. That's what we get out of the function. So now we're going to evaluate a function, okay? So if I said f of x is 2x squared plus 4. That's my rule. Take x, square it, multiply it by 2, add 4, okay? So x, those are my inputs. F of x, those are what I get out. So if x is 0, and I want to evaluate f of x for 0, f of 0 would be when I plug in 0 for x. So f of 0 is 4. So if you saw the words evaluate f of 10, well, I would take f of x, which is 2x squared plus 4. And I'd plug in 10 wherever I see an x. So f of 10 is 204. Okay. So if they could put it backwards to me as well. They could say determine the value of x if f of x equals 23. So now they're telling me that the end result, what I get out, is 23. So I know that f of x is 2x squared plus 4. So I'm going to replace f of x with 2x squared plus 4. Oop, should make that 22. Okay, so I'm going to subtract 4 from both sides. I'm solving for x now. 2x squared equals 18 divided by 2. X squared is 9. So if I take the square root, x could be 3 or negative 3. So plus or minus 3. Okay. So that's what we have. So in this case, my input would have been 10. My output would have been 204. In this case, my input would have been positive or negative 3. So plus or minus 3. And my output was 22. Okay, so this kind of goes back to, when we were in middle school and we were talking about functions. Okay, we can also use this for talking about different sorts of rules. So we could write this another way. We could say that this rule is used for coordinates. So let's say I'm using a function rule for coordinates. And I'd start with, maybe my rule is called, we'll call my rule f. F of x, y. And what they'll give you is they'll tell you the rule by saying that this is going to go to 2x, comma, 3y plus 1. Okay. So, if I wanted to do this, let's say I was doing f of 2, comma 1. Well, whenever I saw an x, I'd put in a 2. And wherever I saw a 1, or y, I'd put in a 1. So this coordinate would now be 4, comma 4. So I took 2, 1 to 4, 4. So if I were to plot that, the original point, x, y, that's my domain, would be 2, 1. And f of 2, 1 is 4, 4. So 1, 2, 3, 4, 1, 2, 3, 4. So that's where this got moved. I could do the same rule. Let's say I want to do f of 3, comma 0. Well, following the same rule, I'm going to take the x and multiply it by 2. So 2 times 3. I'm going to take the 0 and multiply it by 3 and add 1. Well, this becomes 6, comma 1. So 3, 0 went to 6, comma 1. Okay. They could also go backwards. They could say, if f of x, y, is say it is 6, comma 10. Find xy. Well, I know that my rule is that take x and multiply it by 2. So 6 is equal to 2x. And take y, multiply it by 3, and add 1. So now I'd solve my two separate equations. 3 is x. Three is y. So xy would have been 3, 3. Make sure you guys can see all that. Okay. So what I'm putting in, that's called my input. Okay. What I'm getting out, that's called my output. Another word for input is called the pre-image. That's the input. Okay? So I might call this point A. That's what I put in. So this point up here, A is 3, 0. Maybe this is, I'll give that a different letter. Maybe up here, B is 3, 0. C is 2, 1. D is, whatever, no D up here. This output would be called C prime. This would be called B prime. And this, what I got out, is called A prime. And you're wondering, what was that, what you got out? Well, this is what I ended with. This is what f of x, y ended up being. And this is the input, 3, 3, to get this. Okay, so input is the pre-image. Okay? And the image is the output. And I call that A prime. That's what happened to A, my pre-image. Okay. So A, just the point itself, is the pre-image. That's what we put in. A prime, with that little mark at the top, that's my output. That's what we get out. Okay? So another example, let's say z, function z, took xy to x plus 1, comma y. And then they wanted me to find what z would be if the point I was putting in A was 3, 0. They want to know what A prime is. So following this rule, the x gets added by 1, that's 4, and the y gets left alone. So this would be my image, this would be my pre-image. So this would be 3 plus 1. Okay. Now let's say they gave me a different point. Let's say they told me that the image, B prime, is 5, 2. And they want me to find B. Well, I know that x plus 1 equals 5, and y equals 2. So, to solve for x is 4, y is 2. Okay, so I can work forwards and backwards. If they give me the image and they want me to find the original, I need to set each of these values equal to this side of the parentheses. If they give me the pre-image and I want to find the image, I need to apply this rule, the adding 1 rule, to the pre-image to find the image. We'll go over a couple more examples in class tomorrow, but I wanted you to see how this would work.